Hello, ladies and gentlemen, and welcome to today's presentation. Today I'm glad to present our new software service, the Mechanicus. So what is the Mechanicus? Mechanicus is your companion for the gearbox design process. Mechanicus makes it easy to design transmission elements and carry out standard calculations, while also providing intuitive access to powerful calculation functions. Mechanicus brings top German research from the FVA directly to your desk. To achieve this, our main goals while developing the Mechanicus are that the Mechanicus should be a gearbox design calculator and also a front end for the FVA simulation hub. For those who don't know, the FVA simulation hub is kinda like the server version of our main tool, the FVA workbench. You can access the simulation hub via REST API and use the FVA workbench on a dedicated server. Because it is designed as a server software, you need some kind of front end, and the Mechanicus is here to provide a front end for the FVA simulation hub. And finally, the third goal of the Mechanicus is providing a way to getting started into the world of FVA calculations. The application scope of the Mechanicus is, as already mentioned, in the design process, where you can use the Mechanicus as a calculator. On the other side, students can check their solutions to exercises they're usually doing by hand, and because we're using practice-proven algorithms in the Mechanicus, the students can rely on the results they create with the Mechanicus. Finally, the Mechanicus provides a customizable front-end for SimUp applications. Because our software, the FVA Workbench, is a quite complex and powerful tool, we need to strip down those complex calculations down to application cases. For example, application case for sale is different than for the quality assurance and so on. So we can provide some little apps using the Mechanicus for different application cases individually for each customer. The main advantages of the Mechanicus are, at the very first, it is directly applicable. You just have to open your browser, type in mechanicus.app, and you can get started using our powerful calculations. On the other hand, the mechanicus.app should be simply and intuitively to use. We take quite a high development effort to make the calculations as simple and as intuitive to use as possible. As already mentioned, the underlying algorithms rely on the FVA Workbench and are therefore practice proven. Finally, because we're continually developing the Mechanicus, new research is always directly available for you. So, without further ado, let's head over to a live demo. If you open the Mechanicus, you're provided with the following starting or overview page, and you can see we have quite a few calculation modules available at this moment. So you can, for example, calculate a cylindrical gear, a notch, an interference fit, a feather key, and also a rolling bearing. You can, of course, also change the language of the UI on the upper right side from English to German and German to English. You can, for example, if you have a feature request, contact us using this contact formula. So to give you an overview over our calculation modules, I will just make an as an example, a calculation for a cylindrical gear. Just click on calculate the cylindrical gear and you're provided with the input form for the calculation. On the left side, we can input our operation data. For example, in this case, I will input 160 kilowatt. This results from an application case of a rolling mill. My engine speed is 375, and I want to get the gear ratio of 2.6. The rolling mill should operate for 20,000 hours safely. And as you maybe already mentioned, while I'm typing in my data on the left side, on the right side the resulting or the proposed geometry is calculated live, and also the power flow is recalculated whenever I change the input data. For example, if I increase the power to 200, you can see the power flow is recalculated as well as the proposed geometry. For presentation or example purposes, I will continue with the 160 kilowatt. After inputting the operating data, we will head over to the geometry, where we can further adjust the proposed gear geometry. For example, if I want to change the number of teeth to 45, I can do so on this side. In this case, I will just rely on the proposed geometry. On the next tab, the load capacity tab, I can also adjust the parameters necessary for the load capacity calculation. For example, in this case, I want to change the input of the gear 1 from 18 chromium 7.6 to, for example, the 16 mangan chrom 5. If the provided results on the lower half of this formula are not sufficient for you, you can always try to search other materials in our database. So I've taken the 16 mangan chrom 5 for my gear number 1, and now I can start the calculation by clicking calculation. If I want, I can type in the title for the calculation job and change the language of the output report. I've changed it in this case to English. After that, I can start the calculation. Our calculation request is sent to the simulation hub, and after finishing the calculation, I can directly head to my result here in the results overview. And in this case, I can have a look on the report, and you're provided with an FVA Workbench calculation report as a result, where you can get all those necessary data in an overview. You can show or have a look on an animated tooth contact, and so on and so forth. Many really detailed results are also provided in this case. The second example I want to show is the calculation of a notch. You're starting with a pre-design step where you can just input, for example, the torsion. In our case, we want to calculate the notch for the cylindrical gear we calculated in the previous step. Therefore, we have a total moment of 4,200 Newton meter. And after getting the proposed shaft diameter, we can adjust our shaft diameter. For example, I will adjust it to 50 millimeter. And if we want, we can just head over to the definition of our notch. In our case, I want to also adjust the load data. For example, the axial load is about 15,000 Newton as a upper value, and our bending moment is oscillating between minus 1000 and 1000 Newton meter. And as you may already have noticed, it's the right side is also responsive to our input. So whatever I change on the left side, it is graphically represented on the right side. After inputting the load data, I can further define my notch geometry. For example, in this case it's a shaft shoulder which I have to parameterize. Our lower shaft diameter is maybe 40 millimeter and our notch radius is 5 millimeter. And the following steps are also quite forward. You can now start the calculation and then can get to the result. So far so good. Let's have a look on last slide for my presentation, because I want to give an overview of what's next. Well, as already mentioned, the mechanicus will be constantly expanded. We will introduce more calculations soon. We will work hard on more usability to make it even easier and even more intuitive to use the mechanicus. And we also want to improve the interoperability. For example, you can design a cylindrical gear in the mechanicus and after that import it into the FVA workbench for further and more complex calculations, for example. With that, I want to say thank you for your attention and try out the mechanicus. Thank you.